expression of electric field field due to an electric dipole at a point on the axis of the dipole, also called the axial point or end-on position. Now consider an electric dipole placed on the x-axis with the negative charge minus q on the origin. It is origin. Now the figure is something like this. This is your y-axis. This is your x-axis. This is your minus q here. And this is your plus q here. And this is the distance is 2a. Now consider a point P along the axis of the dipole, at which this is the point P, at which the electric field is to be determined. Electric field is to be determined. Now the point P is at a distance r from the center of the dipole, that is this is the center of the dipole, and this is at a distance r. Now the point P is at a distance r minus a from plus q. That is this, from here to here it is r minus a, because this whole is much is r and this much is a. So this point is r minus a. The point P is at a distance. It is at a distance r plus a from minus q. That is from here till here. It is r plus a, this much. Now the electric field due to the plus charge, see here at this point, the electric field at this point due to the plus charge would be in this direction, and for the minus charge the electric field will be in this direction. For the minus charge. Now the electric field due to plus q at P is EQ you take plus 1 by 4 pi epsilon naught q upon r minus A whole square I cap. Now, the electric field due to minus Q at P is, electric field due to minus Q is, let us write it properly, minus Q here. This is due to minus Q is equal to 1 by 4 pi epsilon naught Q upon R plus A whole square minus I cap. Why minus I cap? Because if you see this figure, the unit vector I cap is in this direction. So it is opposite to the I cap, the x-axis. That's why the minus sign. This minus sign is because it is opposite to the direction of positive x-axis. Now the net electric field at point P is E equal to E plus Q due to plus Q charge and E minus Q charge. So this is going to become 1 by 4 pi epsilon naught Q upon R minus A whole square I cap and plus 1 by 4 pi epsilon naught Q R plus A whole square minus I cap. Now this is going to become, take common out, 1 by 4 pi epsilon naught Q bracket into Q into this. So let's write it properly this way only. That would be a better option. Let's write it here only. Then 1 upon R minus A whole square minus 1 upon R plus A whole square I cap. Now you take the LCM. LCM is Q by 4 pi epsilon naught 4. Epsilon naught. Take, this is A minus B and this is A plus B. So A square minus B square, and there is a square on the top. Whole square. This will be R plus A whole square minus R minus A whole square I cap. So now this is going to become Q by 4 pi epsilon naught. This is going to become R square minus A square whole square. This is open up A plus B whole square, R square, A square plus 2RA minus A minus B whole square is A square minus B square, A square plus B square minus 2AB. A square, then this will become this, plus 2RA, and this is going to become I cap. Oh, wait a minute, let me rewrite the whole thing again. Wait a minute. Yes, here it is. Your R plus R square minus A square whole square. This is going to become R square, A square, little bit of space, wait a minute, plus A square plus 2RA minus R square minus A square plus 2RA bracket I cap. So this, and this goes off. So what you are left with, the electric field is now Q by 4 pi epsilon naught 4RA I cap upon R square minus A square whole square. Now if you see the electric dipole moment, P is Q into 2A I cap, because it is always directed from, the electric dipole is directed from, P is directed from, let me write, P is directed from, let's write here, P is directed from negative charge, negative Q2 plus Q, let me write like this, from minus Q to plus Q, minus Q to plus Q. So now you can write E as this is small p, this is small p. Achha, this is small p. So this is equal to Q into 2A into 2R I cap. You take this I cap here, no problem. You take this I cap with this, no problem. You take the I cap with this into 2R upon 4 pi epsilon naught R square minus A square whole square, and this whole quantity is nothing but this. So this is going to be P vector into 2R upon 4 pi epsilon naught R square minus A square whole square. Now see here one thing. Basically, the electric field is always directed from the plus charge to the minus charge. See this. The electric field is always directed from plus to the minus charge as we have seen earlier. But in this case, electric field हर समय directed होता है plus से minus charge की तरफ. But in this case, यहाँ पे it is directed from minus to plus. It is directed from minus to plus charge. This is the thing here. And E is therefore E here, E is directed is in the direction of electric dipole moment, is in the direction of electric dipole moment. Yes, E is in the direction of the electric dipole moment P. And one more thing you can see from here, if R is greater than A, very much greater than A, then R square minus A square tends to R square. So this expression, electric field, becomes 2P vector R upon 4 pi epsilon naught R square it is, and there is a square here, R to the power of 4. So this becomes 2P, this will cancel with this. So this will become 4 pi epsilon naught R cube. So if you see one thing, the electric field is inversely proportional to R cube. Therefore, the graph of this is something like this. This is your electric field. This is your R. The graph is somewhat like this. Wait a minute. I've taught you in the chapter of graph in mathematics. The graph is somewhat like this. This is like that graph of y equal to 1 upon R cube, this type. Y and this R, x cube, sorry. X, and you have this type of a graph. This I have already told you in the chapter of graph in mathematics. You can rub this now. Now one question would come in your mind. Suppose what I do is that I do one thing. I change this, I put plus charge here and a minus charge here. What will happen then? If I reverse this, what is going to happen? मैंने यहाँ पे मैं प्लस चार्ज रखूं और यहाँ पे इलेक्ट्रिक डाइपोल का माइनस चार्ज रखूं. यहाँ पे देखो क्या होता है. This will be in a different direction. Then this will become positive. This will become negative with a minus I, and this will become with a plus I. Here in this case, there will be a minus sign here. You have to put a minus sign here in this portion. You have to put a minus sign here. यहाँ पे एक minus sign आएगा, जिसके कारण यहाँ पे भी एक minus sign आएगा. There will be a minus sign here. And sorry, in this case, the dipole moment will also have a minus sign. The dipole moment will have a minus sign because now the electric dipole will be directed in the opposite sense. And then this will come the same. This final answer will be the same. The final answer will be the same because this minus sign that will come here will get absorbed here because of a minus sign here. So this answer will be same. Okay. Now this was your expression for the electric dipole moment. This was the expression. This two. This one and this one. Of course, you should know the graph also. That's why I told you the graph.